Hello students, so far we discussed the difference curve. Now we want to explain a little bit to you about the slope of the indifference curve, right? So let us say for a consumer whose utility U depends on X and Y, right? The consumer is consuming commodity X and commodity Y, he is deriving satisfaction, right? So his utility function, then his indifference curve in his utility function then can be given by this. U utility depend on f of x and y. We depict the relationship by plotting indifference curves with y on the vertical axis and x on the horizontal axis of the graph, right? And now so let us do that. Actually we should do this in the next page because we are soon going to discuss, but this is how much of good X, how many units of good X he will consume, right? You see all those units, and this is Y, how many units of Y he will good Y he will consume. Is that okay? And then this is the indifference curve U and utility depends on X and Y, right? And now each indifference curve corresponds to a specific level of utility. So U is a constant on a particular curve, as we said, remember? So this is U bar. Let us call this U bar 0. Then for another one, you have another utility indifference curve, you will have U1 bar. Then this one, another utility, you will have U2 bar. See that along each indifference curve, all these are different combinations of x and y. They show us the same level of utility. For this one, the level is U0 bar, see? And for this one, look at all those other combinations. I'm just showing you some examples, right? But there are so many combinations of good x and good y that he can consume. And for this curve, it is U1, right? Okay, and then you can see that you have get the idea now. For all these different combinations, he gets that. So along the same indifference curve, we have the same level of utility. It will not change when you go from one utility to another utility, right? See, this one represent is lower, so this one represent lower level of utility than this U1, which one in turn represent lower level of utility than U2, right? Because this is because easy to see that at on this indifference curve, right? We are consuming, the consumer is consuming less of x and y, right? So all these combinations show less of x and y values than all these combinations, right? So therefore this one must be smaller. So utility for U0 lower than utility for this one and lower than utility for the other one, right? Okay. Well, so let us now then go to the next page, and with which the consumer substitutes good y by good x while still remaining on the same indifference curve. So this one is telling us what? So let us go back. The marginal rate of substitution they are defining. This one MRS we define is what? MRS we define as is the rate at which the consumer substitutes good y by good x while still remaining on the same indifference curve. MRS is measured by the negative of the slope of the indifference curve. So MRS is equal to this one. MRS marginal rate of substitution is the negative of the slope of the indifference curve. See, we can find this from the utility function using implicit differentiation that we have already used here, right? So we will show you. Just for a moment, let us go back. Slope of the indifference curve, let us see draw a tangent. The tangent touch the indifference curve at that point, therefore slope of the indifference curve at that point will be what? Will be also the slope of the tangent. Now this slope the negative of this slope we are calling MRS. That is what we wanted to say. See MRS, and then and you can also see that from one point to the other you can draw many tangents, and each of those tangents will have a different slope, hence different MRS, right? Okay. The optimum consumption position for a consumer is at point A in figure 8.1. We will show you soon. This occurs at a point of tangency between the budget line and the indifference curve, so that the slope of the budget line and the indifference curve are equal. We use the result shown in section 2.7 that the slope of the budget line is the ratio of prices px and py. So if we want to draw another graph here to explain those to you, we are measuring x here, y on the vertical axis, and this is the budget line. See that? And here this is the tangency between the budget line and the indifference curve, right? And now that and at that point the utility is maximized. This is the tangent, right? So this is the optimum. This is where this is how much y he will consume, this is how much x he will consume, and this is optimum consumption, because look at that. Given this budget line, given his ability to buy as reflected by this budget line, this tangency shows the maximum utility he can get, right? So if the consumer is getting anything else, he will be at a lower indifference curve. Only here at the tangent is the utility maximized, so we have the optimum consumption, maximum utility, it is there. Now we have shown, we can show you that if that slope of that budget line, slope of this budget line is this one, is the ratio of prices, a negative of the ratio of prices. Here in the numerator we have price of x, this one, and in the denominator we have price of y. See this one, price of y, this one. So, and that one, that is the slope of the budget line, which also is tangent to that point on the indifference curve, and the indifference curve at that and the slope of the indifference curve is equal to slope of the budget line. Hence MRS equal to what? Negative of the slope, change in y divided by change in x. See, just imagine we are measuring, and here this is the change in y, this is the change in x. So the ratio gives us the slope, and slope of the tangent at that point is equal to this ratio of price, and also equal to this MRS. See, now this was the graph, right? And now we want to draw the, now we want to show you the calculus. So see, MRS equal to what? MRS equal to price of x divided by price of y, the price ratio here, which is equal to marginal utility of x divided by marginal utility of y. See, so here so this marginal utility of x is the derivative of partial derivative of u with respect to x, and that marginal utility of y is the partial derivative of u with respect to y. See that? Okay. Now on a particular indifference curve we have u equal to f is a function of x and y, and this is a constant, we know that, because along the same indifference curve the utility remains fixed, it will not change. The formula for implicit differentiation gives the slope of the indifference curve as this one, change in y divided by change in x. That slope, right here, that slope is equal to the negative of the ratio of the partial derivatives, which stand as we have seen, these are the same things. Taking negative of it, we can get that we can show you that MRA is then equal to this ratio of these marginal utilities, right? So see, MRA is equal to the ratio of prices, and ratio of prices equal to marginal utility also. Hence, we can just equate them those together. So this is the case. And here, marginal. They are now explaining the partial derivative. Therefore, represents the marginal utilities. This one here, this one is marginal utility of x, and this one tells us how much utility will change when x increases by 1 unit. On the other hand, this one is marginal utility of y. This one tells us how much total utility will change when when y consumption of y increases by 1 unit. So these are the two, and we substitute them in this equation, and then simplify. You will see that if you substitute these two, that delta y will cancel out, simplify, and you get this. And in the end, we get that multiply at the point of tangency with the budget line, the slope of the indifference curve equals to slope of the tangent, right? This is the budget line, and this is the indifference curve, tangent at that point. At that point, slope of the budget line, this delta y and delta x equal to what? Yeah, delta y equal to delta x is equal to slope of the budget line also. And then that slope of the budget line is what? You know that here price ratio of prices, px equal to over py. See that? And it's a negative slope line. So see, this one will be what? It's a negative line. So at any point of tangency, the budget line, the slope of the indifference curve is equal to the slope of the budget line, or in symbol, this is the case. Multiply through by 1 gives us the required result then, right? So this one that one is equal to slope of this one. See, slope of this. Okay, so we can now safely say one thing. We can now safely say that we have established that what MRS always marginal rate of substitution will be the ratio of the utilities of x and y, right? Utilities of marginal utilities of x divided by marginal utilities of y, which will in turn be equal to price of x divided by price of y. So ratio of marginal utilities will be equal to ratio of prices, right? So here they give us an example. Look at that, 8.7. Suppose a consumer has the utility function u equal to 10 x raised to the power half y raised to the power y raised to the x raised to the power of let me see, 1/2 and y raised to the power 2/3. Y raised to the power 2/3. Find an expression for the consumer's marginal rate of substitution. So this is u equal to make things clear, let us write down u10 raised to the power half y raised to the power 2 over 3. See that? Okay. Compare the value of the MRS at the point this one, when this is x, this is y, with that at the point on the indifference curve at which 9 units of x are consumed. That is the question they are asking. So let us see what are we going to do. We are going to use this result, and to do that we have to do what? We have to differentiate that utility function, partial differentiate with x and y. So given this, let us now differentiate that one with respect to x first. See that 10 is a constant, and then half is exponent. We are differentiating with x, so half will come in front and sit, get multiply with 10, and then half minus 1, right, power function rule. Y 2 over 3 we just treat as a constant. So this is 10, and this is 2 and 5 cancel out, so this is 5 x, x half minus 1 is minus half, y raised to the power 2 over 3. See that? So that is the partial derivative of u with respect to x, right? It is 5 x raised to the power minus half and multiplied by y raised to the power 2 over 3. And now then differentiate that u with y, let us see. So differentiating all of this with y now. So keep 10x half as constant, and now that y raised to the power 2 over 3, if we differentiate, it will become 2 over 3. The exponent comes and gets multiplied in front, and then 2 over 3 might lose power 1, right? And now here if we simplify, this will be 20. 10 and 2, 20 divided by 3, x raised to the power half, and y raised to the power what? Minus 1 over 3. Is that okay? Okay. And now we want to find out what? We have, let me see, let me change color. Here this is MRS. So this is marginal utility with respect to x. This is, I'm just marginal utility with respect to y. Alright, introducing those notations. And now what happened? Now we know we want to find out MRS. MRS equal to what? We know is given as marginal utility of x, marginal utility of y. So let us bring those together. This one is what? 5 x raised to the power minus half y 2 over 3. See? And in the bottom we have what? Marginal utility of y is 20 over 3, and then x raised to the power half, y raised to the power minus 1 over 3. See that? So now let us simplify. If we simplify, what do we get? So this 5, and then what we can do is that we can 5, and then x raised to the power minus half we can take in the denominator, and also and then that minus half in the denominator will be added to the x raised to the power half, this half, and we just get x in the denominator. And on the other hand, 20 and 3, if we simplify this, it will be 20, and then 3 will go in the numerator, right, and get multiplied. And then this y minus 1 over 3, let us take it in the numerator, and that 2 over 3 and add 2 over 3, add 1 over 3. This minus 1 over 3 will become, this one will become positive when we bring it in front, bring it on top, right? So it will become just y, right? So now let us simplify. This is 5, and then cancel 4. So this is 3 over 4, and this is y, and this is x. So the MRS will be this one. See, MRS will be this one. Now find the value of MRS at point this one. Now substitute for x, you put this one 45, right? 45 point what? 5625, and for y we will substitute that 8, and we solve. If you solve, you will see that what? If you solve, you will see that MRS then becomes what? 0.1317. And if you put them this in the utility x and y, you will see that total utility in this case will be what? 270. Okay, now they are saying that if utilities for the next part, compare the value. So this is done, right? We have this. Now compare the value of MRS at point this with that at the point on the same indifference curve at which 9 units of x are consumed. So instead of this x, so 9 units of x are consumed, is instead of consuming 45 units of x, consume 9 units of x, right? Is consumed. So now now we know that for that part utility will be 270. We don't allow it to change. So we said that the same indifference curve, so we know that utility, total utility will not change. It will be 270 70, right? And but at which x units of x are consumed. Now we are talking about x units of x are consumed. So MRS, when where we are consuming x units of and x 9 units of x is consumed is this one. So we can find that this is y equal to 2 over 3 is equal to what? Equal to see some 270, substitute here, and then x is 9. So we can simplify that and show you that y 2 over 3 is equal to 9, right? And then we simplify further, isolate y, and then this one will be 9 3 over 2. See that? And then that one will be what? That one will be 27. Y equal to 27. And this so this will be the new combination, right? So 9 and 27. And now if we want to show you and what is MRS at that point? MRS at that point, see, we have to substitute those values in here, right? X equal to 9, y equal to 27. If you substitute and if you solve, you will get the value 2.25, right? Okay. And then if we want to let us show you the graph. If we want to show you the graph, we can quickly do a sketch here. This is x, this is y axis, like this. And here what happens is u is utility 270, right? And we said that this will be a point such as A, this will be a point such as B, and here this one x is 9 and y is 27, and at that point we know the original point, right? 45 point what? That one 45.5625 and all, and this y amount of y consumed is 8. See, so those are the 2 points, and we have also calculated this is MRS at this point, this is MRS at what? At that point, right? Okay, so that is the answer for this part.